Alright, so I'm looking at question 7. A particle moving in simple harmonic motion has this differential equation. X double dot is minus 9x, okay? Now, part 1 is just a standard result, right? Show that x equals a sine 3t plus alpha is a solution, but this function is a solution to this differential equation. So you just take both sides, you differentiate it twice to get the left-hand side, you just multiply it by minus 9 to get the right-hand side, and it works, okay? So far so good. Part 2 is where it gets fun. Now it says initially the particle's acceleration is, and then it gives you a speed. So that's partly unfortunate, but you maybe want to correct on your sheet. The particle's acceleration is 18 meters per second. So it should be to the power of minus 2, okay? So when time equals 0, right, you've got x double dot being equal to 18. Also, you get this other condition when t is 5 pi on 18, which is an awkward number, the velocity is 12. Show that the amplitude of the motion is 4 meters, okay? So what I'm required to get is this result, okay? Because I do have that A actually specified for me, alright? So, how do I get this to work? Part of the reason why it's confusing is because you've got all of these equations and they're not all in the same variable, right? So that's why, like, some things in terms of time, some things in terms of displacement, what do you do, okay? So where I'm going to begin is with this initial condition. T equals 0, acceleration is 18, okay? Now if I know the acceleration, because of this equation, I should also know my position, right? So if my acceleration is 18, right, that means that 18 is equal to minus 9x, right, at initial conditions, yeah? So that implies this is where I begin. X is equal to minus 2. Are you happy with that so far? Okay, now, what do I do with this? Well, I'm going to bring it back to this equation that I proved in part 1, right? Because that links time, namely time 0, and displacement, okay? Because I'm trying to get an A. That's what I'm trying to work out, okay? So I'm going to say when t equals 0, after this, x equals minus 2. So I'm going to bring that into my displacement equation. So minus 2 equals a sine, now, times 0, so 3 times t is 0, plus alpha, it's just alpha, okay? Now, I'm going to get another equation in a second that will allow me to solve for this, right? So in order to get an A, I want to say sine alpha is equal to minus 2 on A. Is that alright? Now, I'll admit, this part's a bit tricky, but as you'll see later, you start to anticipate this kind of thing. I'm going to need cos alpha as well, because it's going to come into my expansion, okay? So I'm going to say cos alpha, use your Pythagorean identity, right? It's going to be plus or minus the square root of 1 minus sine squared. Right? 1 minus sine squared, keep this in, take square root, okay? So that's going to be 1 plus 4 over a squared. You happy with that? Okay, just tuck that in your mind for later. Now, the next piece of information they've given us, right? I've sort of exhausted this line. So now I've got to go to velocity. Okay, I don't have a velocity equation, so let's make one. Okay, I've got displacement, so I can get velocity from that. Velocity is equal to, just differentiate. Chain rule, 3 comes out the front. Sine turns into cosine. And now we have a velocity equation in terms of time, right? So that's what I'm going to bring this into, okay? So if I substitute that in, what am I going to get? I'll have 12 over this side. I've got 3a. Now, don't forget, that a is what I'm after, okay? 3a cos 3t, there's t, so multiply by 3, 5 pi on 6 plus alpha, okay? So what do I do with that? Well, if I want to bring this into play, which is my other piece of information, then I'm going to need to use the expansion, right? So I'm going to have, well, I suppose I can divide by 3. So that gives me 4 equals a. All right, think back. What's your expansion for cos a plus b? This is cos minus sine, right? Sorry, my bracket coming in. So cos 5 pi on 6 and cos alpha, right? Now you can see why I brought this result in. Minus sine the same and sine the same. Okay, so far so good? Now, what's going on here? This A, I'm going to leave that out the front. We'll get rid of it in a second. Cos 5 pi on 6. How good are your exact values? 5 pi on 6, it goes down, so it's negative. It's going to be minus root 3 on 2. You're like, yeah, that's exactly what I was going to say. Cos alpha, now I know what cos alpha is. Now I'm going to take the positive value, okay? I'm going to take it as if alpha is acute. So first quadrant. Because when you're thinking about shift, which is where this equation is coming from, right? Why would you shift any further than that? Right? So I can actually sort of assume it's positive. So that's going to give me this, 1 plus 4 on a squared, but which looks awful. But have some faith, okay? Yeah, is that okay? Yeah? So I've got sine 5 pi on 6, which is, okay, so same as sine pi on 6, so it's just a half. Sine alpha, that's sine alpha. Okay. Minus 2 on A. Okay, now, have a look at this. This all looks terrible, but this A out the front is the key, okay? So when this A comes underneath the square root, right, it's going to become A squared, yes? So this is going to be minus root 3 on 2. This is going to become A squared plus 4. Okay, then you have a look at this guy. You're like, this is really A on 2 and 2 on A. And there's a double negative. So it's just 1. Yeah? That's really 4, right? So now when I take it over, 3 minus root 3 on, sorry, that's meant to be a 3, on 2 and A squared plus 4. Now you can almost see it didn't matter whether I took the negative value for cos or not, because in a second I'm going to square out, okay? Bring this over, so let's see here. That's going to be 6 on root 3. That's just 2 root 3, isn't it? Yes? A squared plus 4. You square it out, that gives you 12. Wait, hold on a second. Something's missing. That should be a minus. What did I miss? That's wrong. Sorry, guys. No one picked it up. I wrote it like 5 times. Come on, guys.
He's like, we're just gonna wait till you crash.
Oh, okay, yeah, thanks.
I was trying to whisper it, so.
Thanks, team. Sorry. Okay, there we go. Okay, there we are. 4 comes over. Now, of course, it doesn't matter whether A is plus or minus, because all I'm interested in is amplitude, which is a scalar, right? So the amplitude is 4. Okay. Now, very simple result, right? In terms of the number, but can you see how many twists and turns we had to go through? The hardest part was the setup, right? It was just a cruel setup, okay? They gave us all these different equations in terms of different things. That's why you've got to be very careful as you go through, okay? Does it make sense?
Yes.
Correct.